Can you launch mine for me? See how it does?
Sure.
Do I have to be there to get points or no?
Well, that's typically how an applied engineering class works.
Okay. Well, I'll have to come at like 5 or 6 p.m.
No, you're not. I've got college class at that time.
Yeah, but that's when I can come.
Who's in the car with you, sir?
My brother and sister. But I'm on my earbuds, so they can't hear you guys.
Mm-hmm. So you're all gonna get COVID together. That's great.
Yeah, well, they're my family, so
So you'll all get COVID together because they haven't set in the rules for the slope show. You sure they're open?
Yes, Brighton opened literally today for season pass holders. Bryn.
Okay. Well, must be nice.
Okay, peace out.
Any piece is a good piece. Okay, so we're gonna kind of walk through. Okay, so what I've got on the screen right now, Kisha, this is the original prototype here. Just because it's all finished and we can kind of walk through what we need to today. I'm not expecting yours to be finished. We are going to be in a mad rush though as soon as we get back from Thanksgiving. So try, and if you have software at home, keep working on it, kind of get it done. I will be here Tuesday, obviously. And if you do want them printed, I will do it for you, but I would rather you do your prints for this. Just trying to get a little bit of education in while we can. It's a tricky, tricky world. So we're going to take a little bit of time here. I want the bell to ring so I can get started. I'm anxious. You know, if you think I'd have lots of time in a 3-hour class, but it doesn't quite work as that way.
Dr. Prescott.
Yes.
So I pretty much finished my 3D model for a bike.
Okay.
And then I tried to use the shell feature to hollow out.
Oh, that's gonna give you, if it's all assembled, you'd have a hard time with the shell.
Okay.
Yeah.
So that only works really for assemblies.
Yeah, you want to do the shell before you assemble it.
Okay.
And then you can hollow them out. Or you can take and offset the profile in and do an extrude cut. But yeah, once you've assembled something, the shell won't work anymore.
All right.
Just because it gets a little too many variables on it. Kind of wigs
Right.
out mathematically.
Right.
Cool, I'm looking forward to see it. I'm looking more forward to printing it.
Yeah.
Alrighty, well, we got 32 seconds to go, and then we're gonna get going full bore. Okay, so we've got at least half the class back. We're kind of cutting it. So today is rocket launch day. We're gonna go out there probably in about an hour from now. Okay. One that gets the parking lot a little emptier. Buses will be on the road. Also gets traffic on Main State Street down a little bit, so we're not being gawked at. I hate being gawked at. So that means for those of you who are online, you're going to leave relatively early today from class because I can't take you with us, and I can't take you into the 3D print room. It's kind of the limitations of where the networks are, and I apologize for that. We are. We're just getting ready for it. Yeah, it's gonna be. You're fine right there. You're fine. It's just gonna take us. It's gonna take about an hour to get set up. So I've got to do some stuff. So you'll be fine. Okay. Okay. So what we're gonna do this first little bit here, while I've got you guys online, is we're gonna go over what you have to do to print. So what I have here are the parts of the original prototype that'll be passed around the class. Once you're done with your model, you do need to save it as, just save as, make sure I'm recording here, and change that to an STL file. We've done this before, so that shouldn't be anything new. I'm just gonna kick these in here real quick so I can have them. And you wanna do that with each part that you have. And I'm just kind of going through this so you get used to the motion and see what you have to do. So then those of you that will be not able to come back, depending on what happens. So like Granger, your numbers keep going up. They've already extended you another week. You're back to the 2nd of December now. You got to get these in control. Hunter, you're probably going to be extended as well. So you just do what you can. You're at which school you're at? Skyline. Skyline's come down. You should be okay. You're down to 3. So I'm not worried about you today. That's a good thing. So I'm just going to finish this last one up here, mainly because I want to show you what we have to do on the print table. So again, multiple of you can use one print table if you're doing all the same color. But we do have one that's ready to go today, and I do want to get that one printing, and so it can be in by tomorrow. Last piece here. Okay, so typically I have maybe 4 or 5 parts, not to be too big. You do not want to print these off as an assembly, even though we've done that before as well, where we've taken assembly, say the whole thing is one STL file and print all thing at once. You can do that, but with the complexity of some of your designs and looking at your sketches that you submitted, you then have a better print result by having them in pieces, okay? And again, if you're having a hard time with the threads because you're not here to do all what we would normally do is do lots and lots of prototype prints, like 3 for each of you, in order to make sure your threads work right. You're just not been here enough to do that. So if you need to, just go to the friction fit, and we can that'll work as well. That's all this one is just friction fits. Okay, once you get the parts all done, and the rest is kind of up to you. You can do the graphics on here, just wrapped engravings. You can do pretty much whatever you want on these handles. Okay, they're yours. Make it what you want it to be. Then when we get into the print room, you're going to take a US jump drive and put all your STL files on that jump drive. Did I get it to you? Got it out. I'm sitting right here. So here you go. And I'll provide a jump file for you to use in class here. You then put them onto a file. And again, if you're at home, you would email me and I'll set up something tonight for you to upload your STLs for print. It won't be for the grade. There's not a grade on submitting them for printing. The grade will come after they're printed and put together. And so that'll be the full assembly piece on there. All right, so the program you're going to use comes from GrabCAD, which is kind of cool, which means it's one you can access if you have your own 3D printer at home that you can print from as well. And it's a pretty good little program. It is kind of robust, kind of fun, not very scary. I got to move it to the screen here, so it'll take just a minute to get that in there. Take that into so you kind of forget. It looks like this. Okay. Now, this is set up. There's 3 large stations in there. And then the little guys are using a different slicer program. And that's what this is. This GrabCAD print is a slicer program, which means it takes your STL file and turns it into G code, or basically robot code, so it can control the print file. We are going to be using, this is the large print here. When you see the trays come up, each square is 2 inches. So we have 2, 4, 6, 8, 10, 12, 14 inches across, 2, 4, 6, 8, 10 deep. That's a 14 by 10 tray. It'll go 22 inches tall. So this is what the size machine you'd use if you're doing helmets, which is kind of a big thing right now. Mandalorian's back running, and so everybody's putting helmets again. What? No, he chose to just do voice. Didn't want to be acting without a face. Get the facts right. Read all the articles. Okay, on this machine, this little bow tie thing will always be there. It is where it collects the particles that are cleaning between the parts. So each machine that you're going to be using has 2 materials. One is a support material that dissolves in a water base. The other is your plastic material. And we're going to use ABS. It's a little stronger. It's a little more expensive, but it's a little stronger. PLA is the corn-based. It's a little cheaper, but it's not as strong. So that's kind of the trade-off there. What's up? Yeah. Now this little bow tie thing, if you're using this machine, you can move that back into this area so you have the full tray. That's what this little dog ear here is for, is you can put your trash there. So it just kind of cleans off the pieces. This will get taller. The taller your part is, the taller this bow tie is. Okay. Now both machines that you have access to, and then do the same thing. There's actually a third one in there that's super, super fine. We're not going to use that one because it's super expensive to use. We'll use it if we have, like in your capstone classes. If you're doing a capstone, you need really fine parts, then we'll use that. But it is super expensive. Okay, so that's this machine. Now, on there, you can switch between the two down here, and you'll see there's several machines loaded. The one we're going to use today is, so this is the 3750, or the 370, sorry, 370, which is the big machine. Today, we're going to set up the 1200, and it's a smaller tray, which is fine. This is actually one of my, I love this machine. This is one of my favorite machines because it's pretty friendly in what it does, okay? So you'll have access to either of these, and depending on how many are rated per time will determine which one we use. It also depends on what color you're wanting to print. So colors get changed out as we use them. Okay, so we're going to try and get this one set up today, and let's start putting some parts in. So you add a part model, and that is your STL file. So that means you have to go and search for it, and I probably should have looked to where I saved that thing. There. And so when you look at your files, the STLs will have this kind of 3D mold behind them. So I'm going to bring one in, and I click on that, and it's going to load it into the part. Now, I'm not going to load all of these for time, but the same process is going to occur every time you guys bring one in. Instead of bringing it in, it's just going to put it in whatever orientation you drew it on. Okay, it's just going to lay it down there. Now, for printing purposes, there's a couple things about this part, and I'm going to rotate it over here on the side. There's a rotation option here. It's called Orient in a slicer, and I'm going to rotate it backwards. If I print it this way, then everything from this level down needs support material. Support material is the expensive stuff. It's a lot more expensive than plastic, which is kind of weird because you can't do the other without it. So that's where they make their money, and that's fine. They're entitled to do that. It's America, and you can make money. Anytime you have an overhang like this little button, it's to have support material underneath it. So your goal on setting these up is to reduce how much material you're using. And there's a couple of tricks to do with this that'll make your print much more effective and a little easier for you to work with and quicker to clean. Okay, so in this matter, I'm going to use a lot of support material. If I take that part, you have to select the part first, and then we rotate, and I rotate it this way, there is no support material needed here. However, we'll turn this to the side. I will need some support material runs up the side, but that's a thin piece that runs up the side and much cheaper than doing the whole base, okay? So verticality here is going to be kind of the helper there. This angle is self-supporting because it's going over just a little bit each time. It will cantilever, it's called a cantilever. It can support that without support. It's kind of a weird way of saying it, but I don't need support material for it to stand up. Now, once you get it in place here and you get it oriented where you want, you can move these around by just taking the arrows. It's a lot like other software we may have used where you just slide it where you need to go. So you put yours, if you do multiple people on one tray, you must put yours all together so you know where it's at, so you have your pieces, then leave room for the next guy to come and load theirs in. Once their tray's full, then we'll print it. Because I imagine when we get back, there'll probably be at least 4 or 5 of you ready to go. And we'll print them just as fast as we can. Keep in mind, these will take a while to print, okay? And I'll show you, this part's 3 inches tall. So I'll give you an idea of how long it's gonna take to print on each of these. Okay, now once it's oriented, I'm gonna click off that guy, and then go through the top here. This is your view. This is your active view. It just puts you back to where we are. The same thing happens here in this view. So just like in SolidWorks, your view orientation. This is a SolidWorks built program, so a lot of the icons will look the same. Occasionally, you're going to bring a part in that turns red. This guy right here will fix it. I was thinking of bring one in. I think I might, maybe. I'll try and get one that wigs out. And yeah, that one did. So this one's I have a little bit of support on here. I try to get it to wig out. If there's a problem with it, this will turn red, your part will turn red. When you get them all in, wait till they're all in there, get all your parts in, then just click here and it will repair all your parts. So don't panic, it'll fix things. It just means that something happened while you're making the STL that didn't quite work, or there's a collision that needs to be addressed. So hit repair all parts and then go back to the solid cube here and you're good. Okay, make sure you do that. Don't send it to the printer if there's an error. If the error doesn't fix, then we got to come back in here and work on SolidWorks to figure out what happened. Okay, this layer here is your slice preview.
Yo, do we end up with the bird's nest if we do that? If we go through with the error, so it'll be like error, and then you say print, and then you end up with bird's nest. Is that what ends up?
Yeah, you will. And in these cases, these will run all night long, and those spools hold 70 centimeters of material, or about 270 yards. So that's a lot of material, and it would be really, really, really sad. Okay, so here's a slice preview. I don't usually do a slice preview, but it goes through, it slices your model, and you can look at this to see where to make adjustments. If you're trying to make things more economical, by all means, take the time to do it. It does take more time to run through this, but what it's going to do is to show you each and every layer. So counting how many layers are going to be used to create this. And again, my highest piece here is 3 inches. The lower one there is 1.5 inches. It's the bottom cap piece. Also my battery compartment all in one. Okay, there it is. There are, for this, there's 310 layers. You can actually play the animation. It'll start and show how it grows. The green is the material. The yellow is the support. So you can see where that's all taking place. And you can kind of get a feel for how things are looking. It's kind of fun, but again, we're at 310 layers. So that's 310 times the machine has to pass over, back and forth to create that. It goes all up to the top, narrows in. You see I get very little support on the inside, which is great. We want to keep that down. When you're done, you just click back here and turn that off, okay? And that it's just kind of fun, but if you get errors that don't show up or don't fix, run that. It'll tell you about where on your model you need to go back into SolidWorks and fix. And usually what happens, and the biggest ones I've seen from student work, is you've made a part and you forget you make this little teeny tiny piece, and it's inside of another part because you were moving or assembling it and you lost it. And so you bring it in again, put it in right, but the first one's inside still, and it's conflicting with sides. That's the most common error I see on students the first time through. Okay, this next one down here is your model information, and it just going to tell you what you got on the screen. It's not a really useful thing, but it will be. This is still in beta. Well, it's actually out of beta. It's still in review. This is a share source software, which means people add to it and build it. So this is be developing more and more as we go. The next one down is your tray settings. So this is the tab. There's ABS in there. It's at a slice height. Is every one of those 310 layers is 0.01 inches in height. That's pretty small. It's gonna take a while to print this. That's how many layers it's gonna take. It tells you the tip size. You can change the tips on your 3D printers to change how fast it extrudes. It's kind of like doing the tip on a frosting bag if you're doing sugar cookies, that kind of thing. I don't know if you guys, it's all guys in here. I don't know how. You're okay with frosting? Okay. I don't know. Some of the examples I would use in college, you're not old enough for. Moving down from here, this is where you start looking at our model. Our model settings, this is going to be really, really important for you, okay? So on the model settings, you have three basic options here. And this is how it's filling the inside of your walls. The first one here is relatively, it's solid. It is dead on solid as can be. Ton of material, takes much longer to print. The next one over is sparse, it's high density still. It's best for high structure, low cost. So you're still gonna get a good wall. It's gonna be strong, but inside it's gonna be a little more fibrous. Yes. Yes. Yeah, this is your rockets are all printed on this setting. Okay, because one, we don't want to shoot, you know, rocks at people. It hurts. Oh, dude, I do CO2 cars, so you print CO2 cars too. And when those hit your ankle, you wish you died. I mean, it just hurts. Have you ever had someone hit your ankle with a baseball bat?
Yeah.
It's like that. Yeah. What's that? But oh yeah, that's out of my area. This last one here is really, really sparse, so it's very, very. You could crush it with your hand. I use this method when we make molds, and I still want to get to that point, but we are so not here enough to get everything done I want to do. We will definitely, for those that take Mechanical 3, I've got so many things planned, and please, if you got room in your schedules, now that you got an electric back, since you got 2 in 1 on this thing, please, please, please do come back. I'd love to have that. So that's the spot. So for the molds, which is like these guys, these are chocolate molds. They actually work. I'm gonna make some more of these. I'm gonna use this guy, one of those. I don't know. We'll make some molds. Get things happening there. And so I'm gonna set this in here. I'm not gonna go solid. I'm gonna go on this. Nothing can change until you select your parts. So you have to make sure you select your parts, or they will default to solid. Then select the density you want, and that you're good. Now you can actually go in on this software, and if I wanted to, and I kind of don't, but I'm going to anyway. If I flip this thing around here, my views, I could take and switch to face and select, oh, maybe not. I haven't done this quite right. They're getting it to where you can just pick different parts and have different densities throughout the shape. I merged these together, so I can't do it. But they were separate, non-merged entities. You can change density. Okay, moving down, this guy that looks like a flying diamond. Okay, this is your support. This is the trick to making your print easy to clean, functional, fast. So I'm gonna click on this one. Again, I'm gonna select my models here. And you wanna leave it on smart, okay? Now you do have options that are like sparse and basic and surround. Sparse minimizes the amount of support material you're doing, but it actually ends up using more than if you want smart. It's kind of messed up in there a little bit with the definition. So, and then there's basic, which is supposed to be still less. Smart is by far the easier one to go. And you can always, when you select these guys, you can look in and see a little bit about them. But I would prefer right now to leave them on smart. It works really well, uses the least amount of material. But right here, it says use model material when needed. So if I click on this now, and I'm just going to go ahead and lock that in by checking off of it. What it's going to do is, and if I run that video again, I'm not going to take the time to do it, but I'm going to show you what it's going to do. So the support that goes all the way up to here, it'll have the support material around the model material. So there'll be a thread of model material that goes straight up, surrounded by support material. The model material is cheaper. So if you can use the model material to support, then it just kind of, and it's surrounded by support, then it just breaks off. It's like scaffolding, and it just works a whole lot easier. Okay, so it's a little cheap to be able to support more and cost less than doing it. And so you want to turn that on. I got my thing floating in the air now. Oh, nice. So that's the big thing on there is just on your smart, just use model material if needed, and it would just make it a little bit cheesier. And so it works pretty good that way. You can do here is your arrange. You can do optimize and then arrange the tray automatically. And it takes what it does is this, if you put yours all together, then someone else puts theirs on, someone else puts their own, it'll jumble them all up and make them maximize the fit. So if you're doing a lot of things, this is a good way to go. But what it does is it places them where they will get the optimum print time. So it works with the way the heads are printed, how to fill this tray all the way. You do have to keep about 1/4 inch between each part. So you just optimized it. So readjust them, which is kind of defeats the purpose of keeping your stuff all together, but that's okay. So I don't use that one an awful lot because usually I'm fine. Then we come down here and current visibility. I don't use this one either. So you can adjust, I do these on. This one you can also go in here and orient the face to plane. So for some of you, like on your hilts, they're in the middle of the handle and they're not sitting on anything. You might want to orient to the plane and tilt it a little bit so that one side's more in contact with the surface, depending on what your shape is. That's one of the things you can do with the orient to plane. You can also make them translucent on the view here so you can see through things. I don't do that at all. If I need to, I'll change my view up here. Another one you want to look at here is your scale. Some of you have a very poor idea of what 6 inches is. I don't know why. It might be an ego thing, but you bring it in here and this thing's like 36 inches tall. Okay. And I'll mess one up here because I know what this is. So if I take this guy and I do scale, it's going to tell me their sizes. There's my 3 inches, so I can see that. You can do a uniform scale and just do everything by not point, by 50%. And once I do that, it's going to reduce the size. Well, that's pretty good, but it reduces the size in all 3 orientations, X, Y, and Z. Okay, well, that's sucky. So let's put that back. Now, you can, if your height's wrong, you can take off the uniform scale and you can actually come in and say, no, I really, really need that to be 2.5. It'll squat that down. It still has the same diameter, but it's going to squish it. Okay, so you can fake out a few things and make them work and make those adjustments. And then if you've done that and you need to change your main part, you can go back and change your model so it matches what you had to change in your print. And so there's a back and forth that goes on here. Okay, and that's kind of the nature of what 3D printing is it's rapid prototyping because we make the prototype to save the cost of building the thing out of metal or wood or whatever else we're using. Okay. Now, did you get those all copied on that jump drive, my friend? Okay. All right, online students, this is where we part. We then go into the 3D print room and set one up, and then we're gonna head right out as soon as that started to launch at 8 o'clock in the morning, launch our rockets. So the rest of the day for you and these guys here, the rocket launch will take maybe 20 minutes. And then the rest is lab time. Okay. So work diligently. I'll have a place where you upload your files to print if need be. And if you get them done, if you want me to put them in the printer tomorrow for you, we can do that. Okay. Any questions before I say see ya? Yeah, I'll do what yeah, I think there's some few cameras going around here on phones. We'll get a few. Yeah. Yep, we'll do that. Absolutely. It won't be a live stream because I'm not set up to do that, but I'll get some video posted. Okay. All right. Anybody else? And with that online, we will see you when I see you because it's a floating target now. And we're going to take these guys into the 3D print room. Okay. Thanks, guys. Appreciate it. and I'm